Hi, hello everyone. This is Vishwajit once again on behalf of strictlyby.com on our class of basics of SQL class 3. Today we are going to discuss more detail on SQL constraints and much more. We are going to get deeper into the SQL basic commands. So let's jump and get to the session. Yes, in our previous class, like we have been discussing with the normalization and constraints. I think I have covered the sessions on normalization in my previous class. If some people do want to know more detail on normalization, you can go ahead and watch the video of class 2. This session, I'm going to convey much more detail on SQL constraints and SQL commands. Okay, what is SQL constraint? What is a constraint actually? What is a constraint? Constraint is nothing but a set of maybe a set of protocols or something, protocols to design a table. Okay, so how far this constraint helps? How far this constraint helps in order to design a database? Normally we design a database and we used to design a table, and then we used to insert the records to the table. And how far this constraint help us? Yes, the uses of constraints are duplications is completely reduced, is eradicated or something. It's eliminated, that's the right word. Duplications is eliminated, and redundant data is bad data. It's a non-model data that is not needed for the business, and much more. Robustness and security. So robustness is nothing but how far the data you are storing, how far you are creating a data model in a secure and robust manner. That belongs to the robustness, and security the same as well. So SQL constraints help us. We can't just simply create a table with all these constraints, because if you are creating a table with many duplications, then there is no then there is no part of having a table in your as a whole. When you are creating a table, you need to have in RDBMS concepts, we need to maintain some kind of hierarchy. Because then there will be no difference between maintaining data in Excel and in an RDBMS databases. So these are the major important things in SQL constraints. It reduces the duplications. Redundant data we can eliminate the redundant data. The robustness is maintained. Security level is maintained, and we can maintain the parent-child relationship. Parent-child relations. Okay, don't worry guys, we are going to look much more detail on these topics. Okay, you just go through, you just be patient and go through what I'm just pronouncing on it. Okay, what are the types of constraints? There are many type of constraints. One is a primary key. Okay, first one is the primary key. So it is and regarding this constraint, regarding the RDBMS concept, primary key concept is much more important in database. Okay, we are going to see even more in detail on primary key. And second one is unique key, and third one is not null. So these are the types of constraints. And fourth one is check constraint, check. And another constraint is like default constraint. and another major constraint is no foreign key. Okay, and regarding this primary key, we are going to see what is a primary key. Yes, what is the use of primary key and what is exactly the primary key does. Yes, in regards to RDBMS databases, the primary key plays a major role. The primary key plays a major role because what is the use of primary key? The primary key, as I said here, the duplication, the redundant data, the robustness, the security, and security, these comes under this primary key. Say for example, if you are creating a table called table A, so you want to eliminate the duplications. Say for example, you are having a data in Excel. It has so many kinds of records, and you are finding, and you say for example you are querying to that table. Select star from table name where name is equal to Satish. So if you happen to query there will be so many Satish there will be found. So there will be n number of record. You will be unable to relate who is the exact one that you are in need of. So in that case, we are going to have a key. We are going to have a key column. That is like for Satish, your ID. For an employee ID is there. In college they will give you an ID, right? So same as that of here. In order to order and arrange the data in a particular manner, that comes under normalization. Again I'm saying it comes under normalization. So SQL constraint comes under normalization process. So in order to get the data, in order to retrieve the data in a faster and efficient manner, in order to eliminate these duplications, in order to eliminate the redundant data, we need a separate key. So if there are 10 Satish, you don't know who is the exact match that you are in need of. So that what you are going to do is like for each and every record you are going to mention a unique ID. That is what the primary key. If there are 10 records, you are going to have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these becomes a unique ID. This becomes an ID for a table. So if there are Satish, if there are Satish now, but now we can identify that Satish is found in 1, 2, 3 and 4. But still you will not be able to make who is an exact match. Is that correct? Because since it is a unique record, since it has some ID, for Satish we are giving an ID column of okay, Satish belongs to 1, this Satish belongs to 2, and third Satish belongs to 3. This is like creating an ID column. That's a key column of it. That is what is called as a primary key. Since then, but now also we are not able to identify the exact match for Satish. So what does happen is like the primary key, it's a combination of, as I said in my previous class, combination of unique and not null. Okay. So what does a unique key says? Say for example, it is a table. We are having ID column, and we are having name, and we are having email, and we are having salary. Okay. So name and email. So if you are defining email column to be unique, only the unique records alone it gets. Say for example, if there is satish@gmail.com, okay, it is already there. Then you have mentioned this email column as a unique column. But if you are trying to insert another record with the same satish@gmail.com, it doesn't accept it, because since email has been given as a unique constraint, unique constraint, it doesn't allow Satish once again. So it doesn't allow Satish once again. Then it will show an exception called violation of unique key constraint. It will show an exception on that. Okay. Then people will ask, what is the difference between unique and primary key? Then what? Because primary key is also unique, like 1 2 3 4 5. Then unique is also like unique one, like it doesn't allow any of the records. Then what is the difference between unique and primary key? Unique key allows a null value. Okay, only one null value. Unique key allows only one nulls. So that concept doesn't comes under primary key. Primary key does not allow null value. If at all, if you are defining ID column as a primary key, it is a combination of unique and not null. Okay, so it has to be unique, like 1 2 3 4 5. It is unique and it should not be null. Okay, then it becomes a primary key. So what is a primary key? Primary key is a combination of unique and not null. When you create a primary key, so as I said, like unique key is for a faster retrieval. So how far, since we are having so many records, we can maintain some kind of an ID column or something in order to distinguish between each and every record. So that is what is primary key with a combination of unique and not null. So when you create a primary key, and how far it is going to retrieve the data faster? Yes, since we are distinguishing each and every record, if there are thousands of records, we are going to distinguish each and every record 1 2 3 4 5, like there's going to be 1,000 different records, so that the retrieval is going to be faster manner. How it is going to happen? Yes, when you create a primary key, clustered index is created to that column. Okay, a clustered index, when you define ID column as a primary key, it's a combination of unique and not null. It satisfies the condition of unique and not null. Okay, and apart from that, and how far the retrieval becomes faster, it's due to the clustered index. When you created a primary key, behind the scene what happens is, like the database, the SQL Server or Oracle database engine has inbuilt understanding. It creates a clustered index on top of this an ID column. So what is an index? Index is nothing but it retrieves the data in a faster manner. It is nothing but for example, if you are having a book, in the index page you are having, right? So in the chapter number 1 is located at page 3. The chapter number 2 is located at page 20. That's a kind of an index. So you can directly look onto that index, and you can directly turn the pages to 20. Instead of turning each and every pages, you can directly go to the 20th page and you can look whatever you want. So that is what is called an index. You please don't worry about index. We are going to have a separate session for index also. So don't worry about this. Just have a mindset on index, like index is going to make retrieval faster and efficient manner, as that we are having in the book. Okay, and I think for each and every column, as a data model creator, as a SQL Server developer and a database admin, it is better to have each and every table should have a primary key. Only one primary key can be created in a table. Okay, only one primary key can be created in a table. So because we cannot create n number of primary keys, then it becomes a data duplications also. Okay, if you are creating 2 primary keys, the SQL Server or database engine or the Oracle doesn't allow you to create another primary key. So if we want to create 2 columns or 3 columns as a primary key, then we have a concept called composite primary key. Okay, So the people, please look onto this carefully. What is our composite primary key? This is same as that of a primary key, same as a feature of primary key. But it has the collection of two or more columns. Say for example your requirement is like this. So I'm having a unique ID. Okay, I'm having a unique ID like this. Say for example, okay. Say for example, I'm having a unique ID like this, and I'm going to be on top of 1 second, guys. I just pause on it. Yes, please excuse me. Like, yes. I just got to drink some water. Okay. Yes, we are talking about composite key, right? Yes, composite key is nothing but same as that of the primary key, and so your requirement will be like this. Like, so you want to have these two columns as a unique key column. So you want these two columns to be as act as a primary key. Okay, as I said, like in a table that can be only one primary key. So if at all if you are in need of more number of columns to act as a primary key, then the feature of composite key comes into picture. So how does this composite key really works in? So please watch carefully, guys, because this is going to be an important thing in this database administration and database development, because as a composite key it involves a complex things also, but it is very easy to understand as well. Okay, say for example you are having table S. Okay, then tables, it becomes a table B. Okay, you're having an ID column, you're having a e-name column. Okay, you're having a email, you're having a salary, you're having a DPT, department number. Okay, in which department he belongs to. Say for example there's a record e-name Satish gmail.com. These are the records, so please try to understand me, because these are the columns. Okay, these are the columns. We will later on our classes we are going to work out more on this database environment, but since then please excuse me. So these is the table name, and these are the columns, and these are the records, these are the rows, these are the values to this column name. And salary is like 10,000 and department is 10. Okay, you no need to worry about these records. So what it is like, say for example okay, say for example you have defined an ID and e-name. Okay, ID or ID and email column. Okay, ID and email column as a composite key. Okay, what is a composite key? It acts as a primary key, but it's a collection of two columns. Okay, collection of two columns. Okay, so when I try to insert Satish, but here in e-name I did not give any unique key or any other constraints. I'm just trying to insert another same record. So okay, we shall better give some other name, because you guys will take in a different manner. Sorry for that. gmail.com. Okay, and salary is 20,000 and department is 20. Okay, so if you're acting like this, so you have defined an ID column and email column to be a composite key. Okay, what you defined, wait 1 second. Yes, so actually you have defined an ID column, ID and email column as a composite key. Okay, what happens here, we are trying to so this ID column and unique key column, this email key column act as a primary key. Okay, what is the feature, what is the unique, what is the feature of primary key? It is a combination of unique and not null. Okay, but what does a composite key have? It is a collection of two columns that combine together and form a uniqueness and not null. Okay, for you to understand in a better manner, I just do like this. Okay, ID column and email column. Okay, one and shatish@gmail.com is already there. Okay, where another you are trying to insert one ename with different name. Ename I did not give any other constraint. I just left this ename as it is. ID, and when I'm trying to insert the same record, once again it will throw an error. Since you have defined these two columns as a primary, as a composite key, you cannot enter the same combination of records. Okay, the exact thing is combination of records. Throw is not allowed more than once. Okay, that is eliminating that becomes a primary key. Okay, primary key, here in primary key it looks only for this particular column alone. Okay, what is a composite key? It looks for the combination of records. One is here, shatish@gmail.com is already here. Okay, then it will look for one. Okay, ename is different, it doesn't care about, we did not give any key to this ename, it doesn't care about that, don't need to worry on this. And when you're trying to insert the same combination of record, one and shatish@gmail.com, it will throw an error, composite key violation, composite primary key violation and error occur. Okay, but now trying to insert, instead of Shatish, if you're writing Rajesh, so Rajesh on gmail.com, you might have a doubt whether so it will insert or not. The people will say that no, it won't insert because an ID is a primary key column. It should have only unique of records. Already one is there, and it should not allow two. Of course not. This is not a primary key. This is a composite key. Composite key is nothing but a combination of column, combination of records. So combination of records in the sense, one shatish@gmail.com is already there. You cannot enter this combination of records once again to the table. Okay, but you can enter n number of probabilities, like one Rajesh. Okay, one Rajesh, you can enter one Rajesh. This is a different combination, right? One Rajesh is a different combination. You can have this. Okay, you need not to worry on this ID, like one is already there, one is already there. You never worry on this. If you are going to worry on this, then it is going to be a primary key. If at all, if this column is alone given a key, then it becomes a primary key. If these two columns have been given in a key, then it becomes a composite key. Okay, and in more detail, I'll use like something like some other name, gag, and again I'm going to use rajesh@gmail.com with different 40 ID or something. Okay. Do you people say what do you infer from this? Do you people say that it will allow this record once again to the table, or it doesn't allow this record? Yes, it doesn't allow this record because one rajesh@gmail.com is already there. So what does a database engine look for when you are creating a composite key? The database engine understands, the database engine combines the columns what you have given in the key. These combines and it forms probabilities of relations. Okay, so if one Rajesh is already present, it doesn't allow this combination of record, one rajesh@gmail.com. It doesn't allow the second record to be inserted in that combinations, but still you can make pradeep@gmail.com. okay, but still you can add this one. Okay, you please don't worry about 1111. It becomes a primary key. We are not bothering about primary key now. We are explaining more detail on the composite key. Composite key is a combination of these two columns. It matches, it looks on the combination of columns. Okay, combination of one, Satish is already there, then it doesn't allow this combination once again to the table. Simple as that. Okay, if I'm going to enter one at satish@gmail.com another time, it doesn't allow. Very simple, because already this combination is there. Okay, if one at rajesh@gmail, if you are trying to enter another record on one at rajesh, then definitely it is not going to allow you to enter the combinations. Okay, so the composite keys are used much more in data warehouse concepts. So more in like on data model creation. So people used to have like that will be two columns. One is for the company ID and one is for the customer ID. So based on these combinations, the records needs to be fetched. So on that case, the primary key, the composite primary key will be much more useful in that case. Okay, actually I just made a simple example of ID and email. So consider on a huge volume of data when you are interacting with the company level of data. So it will be like maybe a company code. In my experience, I'm saying the company code or country code. These two combinations. So say for example, if there is a country code for North America, they have given, for India they have given 10, and for India they have given 10, and country code and company ID, and company ID is already 1. Okay, there are combination of two columns like country code and company code. Okay, if country code is 10 and the company code is 1, if this combination is already there, then you cannot enter this combination once again. Then it throws an error. Primary key validation is already there. Okay, so you can enter a different company code only. Okay, so these are real-time examples when you are dealing with real-time data, when you are dealing with some clients, the customers will ask like this. Okay, so based on these two columns, they need to pick the records. That becomes the composite key. Okay, I think we have gone through this unique key. Unique key is nothing but it is going to maintain a unique records, but it is going to allow only one null. That is the difference between unique key and primary key constraint. Another important difference is that the unique key constraint doesn't create an index on top of any column, but the primary key does. What does it create? Yes, the clustered index. It creates a clustered index on top of that column. Okay, that becomes a for faster retrieval. If you are defining a unique key on top of this column, the retrieval can still be faster, but not in an efficient manner when you compare with the primary key. Okay, that's what the primary key, that's what the unique key is. Unique key, we composite, and primary keys are and not null. Not null is nothing but if you want this name column to be not null, like name, there will be requirement like for name the name has to be present. There should not be any null values. So in that case, you can give not null to this column. You can declare not null to this column. Okay. So check constraints is nothing but it's a where condition. It's a condition for checking some values. Okay. So what is a constraint? What does a check constraint do? Sorry, I just clicked something. Okay. What does a check constraint do? Check constraint, say for example, it checks for some conditions. Say for example, we are having, consider this example, we are having a table B, ID, email, ID, name, email, salary and department. Okay, you are declaring check, you are checking this salary column to be greater than 5,000. Okay, or shall I give like greater than? Sorry, I just really measure that. That's the department number, right? Sorry. So I'm checking this salary to be like greater than 10,000. Okay. Checking the salary to be greater than 10,000. I'm declaring the constraint as, so this salary has to be greater than 10,000. Okay. So what happens here when you're trying to insert this record, because it is lesser than 10,000. Okay, I'm not giving any, so I don't want to mess up with so I'll just have like 9,000. Okay. So when you are declared salary check greater than 10,000, this is a check constraint for this column. So what happens to this record? You cannot enter this record. Okay, since then actually this record is always found, it's already found. I just want to consider these are the records that are available. So 20,000 it can. So when you are trying to insert a record that is below 10,000, you cannot enter the record. When you are trying to insert like this, it checks the salary column, checks for this. Since you have given the check constraint, it checks this condition with some values. That value is called this 10,000. It checks whether this record has a salary of 10,000. If it doesn't have greater than 10,000, then this record will be violated. So replicating as like a check constraint key violated. Okay. So you cannot enter 9,000 once again. Okay, but you can enter greater than 9,000. Now I enter 90,000. When I am trying to insert this entire record, then it's going to be inserted in this, because since it is greater than 10,000, right? Okay, that is what the check constraint really helps us. Okay, great. And default constraints. So what is a default constraint? Say for example, ID, email. So we can reuse the same example as well. So ID, email, salary, and department number. So I'm the consider, and you can defaultly mention the department number to be 10. So if your default is 10, okay. If you are declaring department number default to be 10, if you are not trying to insert any record to that table, unless and until if you are not passing any arguments to this department number, then it is going to take us 10. Okay. Say for example, I am going to insert like this on gmail.com. When I am trying to insert like this, it doesn't insert as null, rather it inserts like this, because since then the default value is 10, it considers the default value to be much more than the null values. Okay, that is what the use of default constraint. And important thing, same as that of primary key, is the foreign key. Okay, what is a foreign key? A column in, making much more spelling mistakes on typing fast. A column in one table refers to a column in another table. Okay, a column in one table refers a column in another table. This another column has to be primary key of that table. Okay, first understand what I'm saying. Like, a column in one table refers to a column in another table. Okay, refers to a column in one table. If you are referring a column to another table, then that key has to be primary key of the table. Don't worry about this, I'm going to give a detailed note on that. Okay, so consider the same example as that. So we are having ID, e-name, email, salary, and department. So here we are. Like ID, e-name, email, salary, and department number. Okay. So we are not having the here when you look on department. So I am declaring this as a foreign key. Foreign key references. You are making references. Okay, you cannot define this as a foreign key, but you have to refer this column to another column in another table. Foreign key references table name, department table of what column? Department ID. Okay. So here department ID is here. Foreign key refers to department table with on top of department ID. Okay, that is what the definition of foreign key. A column in one table. This is a column in one table refers a column in another table. That column, that is the department ID column, has to be a primary key of the table. Okay, it is called as. Okay, so since then we are having the employee details here. So for having if you want to look on much more detail on the department items, you can go ahead and create the references table as well. Okay, so this department number is it's a kind of a lookup key. It doesn't have the details of the department entirely here. So if you want to look much more detail on the department, you have to find it here in this department table. So it's a kind of a parent table. Department is a kind of a parent table for this department one. Okay, so consider that there's a table called department table. So then ID is going to be DPT ID, and its D name, department name, and it's going to be the location. Okay, so department ID is going to be 20, sales, location is Chennai, etc. And 42, development, Bengaluru. Okay, then 10, IT support, Mumbai. Okay, so this is a parent table. So this department table has the details of the department, in which what is the name of the department, in which location it belongs to, and what is the revenue it has arrived. So all the department related stuffs can be found here in department table. All the employee related stuffs can be found in these two tables. So since as a concept of RDBMS, we should have some column as a unique column, so that you should have to relate these two tables so that you can save a data in a better manner. That is what the concept of RDBMS really is. That is what we are making here. Okay, so we are not storing department here entirely in this table. So if you want to store the department information here also, then you have to store all these informations in a single table. So what happens if a department table has 20 columns, then these columns have to be accommodated in employee column. So that was a previous DBMS concepts and previous Excel concepts. But our DBMS concept is nothing but split these two tables, split the single table into two tables or multiple tables or many relations. So another department table, the splitter, only the department relevant information is available here. So when you want the department information alone, you can go straight away to this department and you can retrieve the query. But when you want a requirement called I want the name of the people who are working under the department of 20, and also I want to know the department name. I want the e-name, their employee name and their department name, who are all coming under department 20. Okay, so if at all that requirement, you can take e-name from this, d-name from this, and you cannot write two different select queries. They want in a single select queries. So to that we are having a key column here. So we have defined, so when coming to foreign key concept, we have defined department to be as a foreign key. What is the concept of foreign key? A column in one table, this is at one table, refers a column on another table, this another table. That key has to be primary key of the table. Here, this column is a primary key, because it has to be a primary key, because it allows only one unique and not null values here. Okay, this is a primary key. Okay, this is a primary key column, and this is what. So when you have this employee table, this department ID column refers this department tables an ID, primary key column, that is department ID. Okay, so this is a kind of a parent and child relations. Okay, what I said is like parent and child relation. This becomes a parent table to this one. Okay, because only one column is found here, right? This becomes a parent table to this department number column. Okay. So what is the real use of a foreign key is that if at all the record is, unless the record is found in a parent column, you cannot enter the record, in the child column. Okay, say for example, when I am trying to enter this array of 12,000. Okay, I am trying to enter straight away to this employee key as 50. It checks to the parent table. Since we have defined it as a foreign key that references to its parent table, that is department table of department, it checks to this department, that's parent table, whether this entered ID is there or not. It checks. Okay, 20 is there, 42 is there, 10 is there, and 50 is not there. Okay, my parent is not having 50, then how can I have it? Okay, then what else? Then throw the error. Foreign key violation. Okay, parent child relation violation. Since it is a 50 thing, it is not found in parent, then how can be it is found in child? That is a simple concept. Okay, so if a parent is going to have 50, say Richard Mumbai, Kolkata. Okay, so if there is going to be a department ID of 50, then this record is accepted. Okay, and if you are trying to enter 50, then it looks okay, it queries to this, it references this department ID, it looks to this department table whether this 50 is there or not. Okay, 50 is there. Okay, then we can allow this 50 here in child also. Okay, if you are referring some column to be as a foreign key column, okay, foreign key column, it checks to that parent database, parent tables, whether that record is available or whether that column, what is the column you have defined in the primary key, is available also or not. If it does not available and we are trying to insert directly to that child table, then it doesn't allow. Okay, the simple concept is like, if you want to do something, you have to get permission from the parent, and then you have to feed the child. Okay, parent to child. Okay, that's the concept of foreign key. I think we have gone through all the constraints, SQL constraints here, and I think it took much time of yours and also mine, and basic, and I'm going to work on my quick references on basic SQL commands. Okay, the much more an important thing on querying a SQL, sorry, I just picked something, sorry for that. So the much more important thing is like querying. What is SQL querying? That is structural query language. How we are going to query. I think we have studied more detail on DDL, DML, TCL and DCL, right? Okay, then we shall maintain the hierarchy. So this concepts, so no blog or no other website doesn't explain about the hierarchy of querying. So based on my experience, I am making out of a, so please utilize in a better manner. Okay, hierarchy of querying. What is a hierarchy of querying? You might have overcome like so many commands like select from table name, where, else, if, group by, order by, having. So there are so many commands in SQL. Okay, there has to be, you cannot simply go ahead and do whatever you want, but there has to be some hierarchy in querying that has to be maintained. Okay, that is a protocol. First, since then you understand the basic concepts of querying, then you can get to know the deeper analysis of whatever you want. Okay, the first thing that comes into the picture is like the select. Okay, I'm making the order. When you're trying to retrieve something from the table, the order is like this. Okay, for data retrieval, I think I'll make it clear. You should not confuse yourself. For data retrieval, the hierarchy is like this: select, column names. So you never worry about the column names. Select column names from. You have to define the table name. Okay, select the column name, table name, where you have to give the condition of where. Okay, where. So first get to know this hierarchy, guys. So select from where. I think yes, I should put it like this. That would be where, group by, having, order by. Okay, so these are the much more hierarchy. You should not be confused. So when you are trying to query a table, this is what the syntax. Maybe in programming language they call it as a syntax. Here we call it as something kind of standards. Okay, select column names. Okay, you can define the specific column names, or else you can give a star. Star refers to all columns. Okay, but the best practice in here is like you have to define each and every column what you want. If you want neither all columns, it is best practice to define all the columns. Okay, and select from table name, then comes into this picture where. You cannot write group by before where. Sorry, you cannot write group by before where conditions. Okay, the hierarchy comes like this. So where, what does a where does? Where it applies the condition. Apply conditions. Okay, so apply conditions on what? On the records, how far the record needs to be. Say for example, I need to get the record of an employee of Shakti's. Okay, select e-name, that is an employee name, or star, select star from table name, where employee name, is Satish. Your employee name is equal to Satish. That is in a condition. Okay. And group by. So, and having and order by. So group by, we are going to look more detail on group by. So first, I want to give a glimpse of what is group by. Okay. Say for example, you consider you are having a table. You please imagine, guys. You consider you are having a table with all the records, employee records, employee details. One Silva email ID and these locations or something is in a sample of table. Okay, you want to get the records for the persons who live in Chennai. Okay, you want to get the records not only in Chennai, you want the records to be in the city wise. Okay, say for example, your requirement is I want the employee records based on the city. Okay, that means the employees who are all working in Chennai, then employees who are all working in Bangalore, and employees who are all working in Mumbai. So that kind of list I do need want. Okay, that will be a requirement. So the group by class, what it does is like, so these are the classes actually. Where class, having, group by, these are the classes. Okay, group by, what it does, you can group by city name. Okay, what happens is like it does a group by based on city. So then the records would be like Chennai, these peoples are there. Okay, Chennai, and Bangalore, these peoples are there. Bangalore. 10 peoples will be out of Bangalore. So group by is like that. Okay, when you want to do something based on some scenarios, you can go for group by is applied on column levels. Okay, on columns. Okay, and having. So actually you need not worry about this group by. So group by is used on aggregated columns. No, actually group by is used when applying aggregations. Okay, when aggregations is applied to a particular column here, then group by is needed. Say aggregations is nothing but sum, average, etc. Okay, so when you're doing aggregations to the specific columns, then you need the group by. Okay, don't worry about this, guys. I just want to look on this hierarchy alone, that is select star from table name where group by order by. You should not forget. Okay, you should not mismatch, you should not confuse yourself which one would come faster. Okay, group by doesn't comes before where. Select star from group by where, that is an improper condition. Okay, at first the people used to make mistakes like this, but it should not be continued. So that's why I am much more keen on making a much more easy way as possible, like select from where, group by, having, and order by. We are going to look for each and everything, and our future classes we are going to look more detail on group by and why it is. Okay, and having. Now it is having. Having is nothing but aggregations. When you want to apply conditions on some columns, you can give where conditions. Okay, but if you want to give any what is that? Any conditions on the aggregated columns, that is sum of average of, then the having comes into the picture. Okay, say for example, if you want to get the sum of salaries greater than 15,000, you cannot give in a where class. Where sum of salary is greater than 15,000, you cannot give there in where in class. Then it is an invalid syntax. You have to give in having. having sum of salary is greater than 10,000, 15,000. Okay, it is for aggregate. Aggregations conditions. Okay, for normal column conditions, where class can be used. For aggregated conditions, you need to have a handle by. Okay, order by is nothing but sorting. Okay, you can sort one or more columns. Okay, sort is nothing but you can sort by ascending, you can sort by descending as well. Okay, we are going to look more detail on these aspects in our future classes. I just want to know, show you the hierarchy. Select from, where, group by. Don't mix up this, guys. So there will be conditions like you have to use only where conditions. Yes, of course you can use. There will be conditions like you have to use only group by. Okay, you need not to use having and order by. But when you are using having, there has to be some group by. Okay, so that kind of important nooks and peaks will be covered in our next session. Okay, and I think it's time to wind up. And thank you guys, and thanks once again for your time, for your valuable time. So subscribe our YouTube channel, Strictly BA Analytics. And this is Spirit signing off once again. Let us get together in our next class. Thanks once again. Thank you everyone for your time.